joining us online from period 3. You are going to have your own that is assigned to you. This is the period 2 one, and so you guys can just mark as done. And you're going to be able to take it with a period 3 one that I'm going to make available to you guys. But what we just did was quiz time. Because you were supposed to solidify your way of doing the unit circle over break. However, I didn't make an actual assignment out of it, so I felt a little bad like having it be a full-blown quiz today. So instead, I had it be a fun quiz today and then a more serious one on Wednesday, which is why we did the quizzes. But the question is, how did you do when it came to be quiz time? People that are here in the classroom, they needed to get out a blank piece of paper. Once we were, quote-unquote, starting the quiz, aka people were going into quizzes, they were, let's see, how many of you guys did start writing the circle out?
I just wrote the...
Maybe like a half. How many of you guys wrote any portion of the circle? Okay, so at least like half the class, but the other half of the class chose to do it a different way. How many of you guys chose to do it with triangles? You were just thinking triangles. How many of you were thinking of the 5 special numbers, like 0, 1, half, root 2 over 2, root 3 over 2? And you were just going maybe the cheater chart or just the numbers themselves? Okay. How many of you guys found over break the finger method, and you did the finger method of the first quadrant?
No.
Interesting. We're going to see today how your current method worked and whether or not you should make any adjustments to your current method. But we're going over the answers. So people that are online, if I were you, I would pause it right now because the point is to see how well your current method works. Open up this one that should be in Google Classroom and have period 3 on it. And then you can go ahead and play the rest of this to see how we went over the questions and what was right, what was wrong, etc. So, those of you guys that are here, who has a specific one you want me to go to?
8.
Was your guys' all in the same order, or did I scramble them? Do you remember?
I don't know.
I wrote question 5.
Uh-oh. 8 is cosine of 4 pi over 3. Is that right or wrong?
Yes.
Yes.
There was also a tangent question.
Oh, it was also...
Is it true?
Maybe we should just go one by one and see if you guys want me to go over anything. Is that better? Because it might have been scrambled. The radius of the unit circle. Everybody, what is it? 1, because it's the unit circle. It's the most basic circle. Was the sine the y coordinate? Yes, y. Because you could draw a triangle, and the y is the same thing as the opposite. So Katoa, opposite over 1 is sine. So then the cosine, was that the one? No, because the cosine is the x. When you're drawing a right triangle at any point of the unit circle, the hypotenuse is equal to 1. Is that true or false? True, because the radius is 1, so it's the same thing. Sine of pi over 6, what quadrant?
1.
And so, since it was 1, should it be a positive or a negative?
Positive.
Okay, so I guess that's not exciting because all of them are positive, but in another question they might not be. And then, question, if sine is, make it exciting, there we go. Sine of pi over 6 is right about, boop, there. Sine is the opposite, boop. Is that the little one or the big one? Who's bigger, the x or the y? The x is bigger, so therefore, boop, there he is, 1/2. What? Because I'm thinking of my 5 special numbers. There's the smallest, that only happens on a quadrant. Then there's the smaller. So sine is the smaller, and then it's the middle. And then it's the bigger. And then it's the biggest. Also known as the cheater chart. 1, 2, 3, sine starts at the 1. Because pi over 6 is a small slice, 1/6. Corresponding my geometry people to what reference angle? Those of you guys that did triangles, you had to get the triangle written. What kind of angle is this? 30. 30, so that's 1/2. How about the next one? 3 pi over 4, what quadrant?
2.
Ooh, so if it's quadrant 2, it could be a negative, it could be a positive. Let's think about it. Question, 3 pi over 4, what's the reference angle, my geometry people? 45, which means that x and y are the exact same, and the x and y for my unit circle people, the only ones that are the exact same are which ones? Not the smaller, but the middle. So it's the root 2 over 2, root 2 over 2, but question, which one's positive and which one's negative? Cosine is negative. You could think all students, sine is the positive one. All students, oh, sorry. Wrote the wrong one. Sine is the positive one because of all students. You could also think that if you were doing geometry, that's going to be positive because it's going up. This is going to be negative because it's going left. And then you could do 1, 1, root 2, which is technically outside of the unit circle. It just needs to be scaled back, but you could get the cosine negative 1 over root 2 and then rationalize it. Cosine is indeed negative and it's at the 45. Andy.
What quadrants are cosine negative?
Cosine is negative in, well, no one's negative in the first quadrant, right? But then cosine's only positive again in the fourth quadrant, which is why all students take C shows up in the fourth quadrant classes. So sine is positive in the first and second, all students. Tangent is positive in the first and in the third, all students take T. And then cosine is positive in the first and in the fourth, all students take classes. Yeah, Michelle. Yeah, don't get lost phone on desk. Good. Is that good? Okay, I'm trying to explain it like all the ways at once. Next one. Where's 5 pi over 6? How do you know that for those that might not be jumping there as quickly?
It's not all the way.
It's 1 pi over 6 shy of what? This is pi, which could be cut into 6 out of 6, right? And then you just go 1 up from that. So it's a 30 degree, but it's a 30 degree over here. And so we just did a 30 degree a little bit ago where it was over a lot and up a little if you're a unit circle-y type. But we just talked about how in this quadrant the cosine is in negative because it's going backwards a lot, and then sine is up a little. You could also think of the cheater chart if you want, because pi over 6 is the very first. Ooh, no, that does not work well. Pause. The cheater chart, for those of you guys that do the values, pi over 6 is the first one after 0. And so for sine, it'd be 1, 2, 3. For cosine, it would be 3, 2, 1. All over 2. But for tangent, there's the sine, there's the cosine, the tangent, square root 3 over 3. Oh, hey, there it is. I just need to remember, like Andy said, who's what. Tangent would be a negative in that quadrant. Cheater chart is how I would have done that one, but you guys could also do this one by taking the, ooh, I heard this right before the quiz, x over y or y over x for tangent.
Y over X.
Mm-hmm.
Wow.
So you would have had to have done y over x. What happens when they're both halves? Mathematically, what can I do to make my life easier? Okay, you could multiply by the reciprocal if you want. I was thinking of reducing the halves from top and bottom. That works too. But I could multiply by the reciprocal, which would get me negative 1 over root 3, which rationalizes to, would you also land at negative root 3 over 3? Yes. My geometry people with the triangle. You could have also realized that was a 30 degree, and so you could have done a 30, 60, 90, where you would have had a positive 1, a 2, and a root 3. Hopefully you would have remembered that was a negative root 3 because it's to the left. You could have done opposite over adjacent, which is 1 over negative root 3, which also gets you to the exact same spot if you rationalize. Let's pause for a second. Tangent is funny. It's in the second quadrant. Questions about cheater chart or about triangle or about unit circle? Right.
Oh, I got negative 1 over pi over, square root of 3. Why did you times it by square root of 3?
Remember, this is called rationalizing. And it was something that showed up a little bit in Algebra 1, should have shown up a little bit in Algebra 1, showed up more in Algebra 2. Typically, we say this is the form that you found. We typically call it unsimplified because we don't like to leave square roots and denominators.
You can't put a ration in the denominator, so to get it to
We don't like square roots and denominators because it's hard to think of, like, if you're portioning into root 3s, it's better to think of portioning into thirds and then having a root on top. But it's the same thing, you just didn't know how to make the match. But it is maybe helpful for you to, I mean, not that you have to memorize the cheater chart, but one is one variation of root 3 over 2 over 1/2 will get you that one, and then 1/2 over root 3 over 2, this is the reciprocal. So they are reciprocals of each other.
would you like us to put it in simplified form?
that's what you would need to do to make the proper match in pre-calc. In calculus, we're kind of like, ain't nobody got time for that because we're doing advanced things, so we just leave things in unsimplified forms sometimes, but in pre-calc, your answers should be in the nicest forms. When you're making the match. If it's a long answer, you can leave it either way. Unless I say rationalize. Any other questions about how to get to negative root 3 over 3? Your way? A way? All the ways? Okay. What quadrant? 4 pi over 3. Sorry, what quadrant? Ooh, which one? Is it more than a whole calzone or is it less than a whole calzone? More, because I have 4/3. Isn't that 1 and a third?
Yeah.
So my ones that eat a calzone, think of your whole calzone, boop, and you had a third more. Boop, boop, there you are. Third quadrant, right? So you have your 3 pi over 3. And another one, so you're at 4 pi over 3. Hey, what's my reference angle to this one, though? If it's a third of 180. My geometry people, you needed to think of the triangle, right? So if it's a third of 180, who is this guy? He's a 60, 30, 90? Or my other people, you need to think about your thirds and needing to match up with the other third that's up here, right? So my unit circle people, your original third would have been over a little, up a lot, so over a little. Oh, sorry, everything's positive, up a lot. But if you're in the third quadrant, what are the signs of those guys? All are positive. Sine is positive. Who's positive in the third quadrant? Is no one doing the signs? You guys all just thinking about lefts and rights? Nobody doing the trick? All are positive. Sine's positive. Who's positive here? So everybody else is negative, right? So you move to the left a little bit. You move down a lot. And who are you wanting if you're doing cosine?
Is that X?
The x. And the x is the little one, not the lot one. Although I didn't draw that super nice, but that's okay. It's the over a little, not the down a lot. So therefore it's the negative 1/2. Cheater chart people. So, ka, toa. 1, 2, 3, 3, 2, 1. Cosine right here. And remember, all of these are all little halves. You just had to think about, oh, it's all students take cosines negative 1/2. And triangle people, I never finished the thought there. I apologize. You would have needed to have seen this is a 60. 60 has the root 3 across from him, which would have been negative because it's going down. It would have had across from the 30 the 1, which is negative because it's left, and then you would have had your 2. And so adjacent over hypotenuse, boom, there he is. Questions going once, going twice? Sold. I think we're almost done, right? Where are we at? 5 pi over 4, what quadrant? Third. What's the reference angle?
Oh, 45.
It is a 45. And if you're doing the cheater chart, it's going to be, it's in the middle. So it's a root 2 over 2, but it's in the third quadrant. Everybody's negative. Dun, 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 dun. It's a 1, 2, 3, 3, 2. 3, 2, 1. So, ka, toa. 1, 2, 3, 3, 2, 1. Add a square root, add an over 2. There he is. But all students take only tangents positive, not cosine. So make him a negative. And then number 10. What quadrant? For 5 pi over 4 again. Same one. Still a 45. Oh, gross. Right? If you have to do y over x and you're at a 45 and you have all these nasty square root things, oh, it's not even the right one. It's the 45, so it's isosceles. So they're both the exact same thing, but they're in the third quadrant. They're both a negative. Ugh. Except, what's going to happen, guys, when you do y over x? Why is it 1, Johnny?
Because everything cancels out.
Everything reduces. We love 45s for tangents because the x's and the y's are the same. Don't make it harder than it has to be. 45s? So, ka, toa, cheater chart. 1, 2, 3, 3, 2, 1, all over 2, square root of 3, over 3. 1, there he is, every 45. Every pi over 4 is a 1. And all students take, he's the positive one. Show me on your hands how many you got right.
Was that a
Woo! It was out of 10.
I actually did like the first two
See, remembering his unit circle. Okay, put him down. So, what are you going to have to do on Wednesday?
Do the same exact thing.
The same exact thing, but a lot shorter. Remember how many questions I was telling you I was going to give you? I'll probably give you 3 and a bonus. They're going to come somewhere within the unit circle. They won't be coterminal, so they won't be like 25, 6 pi. That'd be gross. But they're going to be 3, probably 1 sine, probably 1 cosine, probably 1 tangent from who knows where. And the bonus will probably be like, guys, are there more trig functions besides SOHCAHTOA? Well, hold on. Who are they, first of all? Cotangent is 1, but I wouldn't start with that one. Why would I start with cosecant?
Because it's
Because it's the reciprocal of who? Sine. And isn't it also SOHCAHTOA, sine, cosine, tangent? How's the other one go? It goes the cosecant, and then the cosecant, then secant, then cotangent. The bonus will probably be one of those. That's better than a normal question. Ryan, go.
So will all the questions just be find the sine of 4 pi over 3?
It'll be just give me the ratio. So here's where I'm going to give points for you guys to know. Because 3 questions, like a quiz, guys, 3 questions on a quiz is kind of rough. Why is it kind of rough?
If you miss one
So, check it. I'm going to make it out of 10 points. 1 point is for free by just putting your name on the paper. So that makes every 3 questions worth how many? 3, right? So 1 is going to be the sign, whether you get the positive or negative right. So if you don't know anything else, tell me the positive or negative. 1 is going to be the ratio. 1 is going to be the sign, 1 is going to be the ratio. What should the other point be?
The correctness.
The correctness.
Work shown.
Do I normally do 4 points? Is that what I do? 4 questions? Work shown? We could say work shown, and all that means is on your half sheet of paper, because you guys are just be doing a half sheet of paper. On your half sheet of paper, you've shown me somehow. You don't have to do it separately, though. But you've shown me something. So either you've shown me triangles, or you've shown me like a circle, or you've shown me like a cheater chart. You've shown me something about what your brain's doing. Okay, we can do that. So 1 is positive or negative. 1 is the correct value, the ratio. And 1 is you have work shown, which technically, think about it, hold on. If you've drawn 1 circle, couldn't that be for all 3? The work for, you don't have to do the circle 3 times. Does that make sense?
Okay.
Okay. And then the bonus will be worth plus 1, which is plus 10%, spoiled rotten. So that's what's coming on Wednesday. Any questions? Ryan?
I was just saying because the quiz said like 4 points, 4.4, and this is like only 1 concept, so what would be tested on?
Oh, this is just like a quick warm-up on Wednesday. Because it's kind of 4.1 through 4.4, because 4.1 we talked about degrees versus radians. 4.2 we talked about just the unit circle itself. 4.3 said, hey, there are triangles, and that's kind of the foundation of it all. And then 4.4 says, what if you go negative? What if you go coterminal? What if you're in a different quadrant? So it's kind of all leading up to this.
So will it just be like find the cosine of 5 pi over 4?
Yeah, it'll literally be like this, with a sine of a random angle in between 0 and 2 pi, a cosine of a random angle, a tangent of a random angle, and then a bonus of a cosecant or secant or cotangent of a random.
But just that concept, not like
Yes,
something
that's it.
else. Okay.
That's it. Now pause really quickly. Didn't I ask you guys something about, did anybody learn the finger trick of the unit circle? Weirdness. Hey, is this a thing?
I guess.
Like, it sure looks like it. I did finger trick, unit circle, and there's a lot of... So what's the finger trick of the unit circle?
Oh,
Because you make a angle.
If you're like a math teacher, you get the tattoo on the hand.
And then these 3.
I don't know.
Tattoo. That's cheating.
I guess you could make this a pi over 6. Whoa, why would I tattoo pi over 6 here? On my knuckle, or like on the flat of my. I wouldn't do knuckles. That's
Thirty.
too much.
That's the first
On the
one.
fat? Pi over 6, this is a 30, right? If this is 0 and this is 90, that's pi over 6. What's this one? Pi over 4. What's this one? Pi over 3. Wait a minute. How does this help by me just knowing, whoa, how many fingers are below?
1.
Isn't the first order pair, or the first coordinate, isn't it 1/2?
Mm-hmm.
And what's the other order pair?
2.
No, it's 1/2 and √3/2, isn't it? Uh-oh. Do we know our unit circle?
Yes.
Wait, I thought it was.
Check it. Let me go back to this one real fast. So if you fold the pi over 6 in your unit circle. Oh, I did it the wrong way, sorry.
Yeah.
The cosine comes first, that's what's on top, and then the sine's what comes next. The cosine's on top, that's √3/2. Count your fingers. 1, 2, there are 3 of them, and then your sine is 1/2. √3/2 and √1/2, which is just 1/2. Pi over 4, what are your coordinates? Well, what are the fingers above and below? √2/2 and √2/2. There's 2 and 2. How about at pi over 3? 1/2 and √3/2. And you can even use it at 0, because at 0 it would be √4/2, which is 2/2, which is 1, and then 0, because there's nothing below. And then here, there's 0 here, and then √4/2 is 1. So you have 0, 1, you have 1/2 √3/2, √2/2, √2/2, √3/2, 1/2, and then 1, 0. If you know your coordinates. Wait a minute, but that's only the first quadrant. Pi over 6, pi over 4, pi over 3, pi over 2. What about the second
You
quadrant?
just switch hands.
You can think of going this way. And then you still have your pi over 2. You still have your pi over 3, but now it's 2 of them. You still have your pi over 4, but it's 3 pi over 4 of them. You still have your pi over 6, but it's 5 pi over 6. And then you still have your, on your x-axis. And you can go, okay, it starts to get awkward after that. But if you know one of them, so can't you just think of moving left and up, or moving left and down, or moving right and down? With the symmetries I talked about before. Anyway, is this the only way to do it? No, but have a lot of teachers tried to show this, because it is something that you can quickly see. Like, oh, it's 2 and 2, or oh, it's 3 and 1, or oh, it's 1 and 3. Anyway, it's an idea. If you guys need to work on your unit circle, it is a snazzy idea to use. Let us get back to our job for today. How many of you guys opened up your WebAssign?
No.
I said as soon as you finish your quiz, you should probably open up your WebAssign.
Oh.
I'm going to take the first 5 questions.
I like my baby turkey.
Your baby turkey? You can make a turkey out of these
Oh,
things.
it's the same one.
A unit circle turkey? Oh my goodness, gobble gobble. Anyway, so, ready?
Oh, a 9.
9, what else?
16, 10, 16,
9,
11, 12,
16,
13.
10. Careful, only 5 questions.
27.
27. One more. 24. I can fit it.
Let's go.
All right. Have you all done these? No. Might it be a good idea to get some paper to, show the thought process for when you get there? Yes. So here we go. Let's go check out number 5. Oh, what? Do we want to change one? Oh, number 9. Sorry. Okay, don't get lost. Number 9. Oh, this is a fun one. Did you guys forget how to do this one? Make the triangle. Question. How can you make a triangle? What? I don't even know the angle. Most of you probably don't even know how to use your calculator to get the angle. But we don't need the angle. Why? Why don't we need the angle? P.S. Right now I'm just saying you want the first quadrant? Sure. Why not? And then why am I making this really, really tall and then pretty?
Oh, because you know the adjacent. That's 1.
I know the adjacent? Oh, then I drew this backwards. Why do I know the adjacent?
Because if cotangent is adjacent.
But 6 wouldn't be in the unit circle. Remember, unit circle, everything the biggest I have of ratios is 1, so this is something outside the unit circle.
Oh, we know x is 6.
Oh, I do know x is 6. and I know y is 1, or at least proportionally I have 6 to 1 with those sides. How do I know that the sides adjacent and then opposite are 6 to 1 from what they just gave me?
It's adjacent over opposite.
I have tau, which means cotangent of any angle, that's the Greek letter alpha, right, is adjacent over opposite, but how did I get 6 and 1?
It's 6 over 6.
There's an understood 1 for any number if they don't give me another denominator, right? So it's 6 to 1 as far as it could be 12 to 2, it could be 24 to 4. I don't know exactly the size of whatever they're trying to tell me, but I know the ratios. But wait, how can they be asking me for things like sine and cosine and tangent? How am I supposed to answer? I don't know the Pythagorean theorem. We can find the hypotenuse because it's 6 squared plus 1 squared is equal to 37 is equal to c squared, and so therefore I just need to square root both sides. So now do I have my full triangle? Yeah, I do. And it's in the first quadrant, which means everybody, always, everybody is positive. So what am I going to do to fill in stuff? I'm going to take my little SOHCAHTOA CHOSHA cow, and I'm going to fill it all in. Oh, they're not even asking me for everything. Tangent just says flip it. I could do that. Cosecant says, what's the hypotenuse? Over cho, opposite, which is just 1. And then you can fill in. Oh, do you guys remember the 90 guy? The 90 guy is a tricky one. We're going to see more in chapter 5. It wouldn't be on a test. But the 91 is cofunction. So the cotangent at 90 is the same thing as tangent at the original angle. Sorry about that. You might want to just make a note of it for now. We'll learn it or see it again in chapter 5. But these two match up because tangent at one angle is his cofunction, cotangent at the complementary angle, hence the co-co. And then you just have to, Ryan, see, they like rationalizing. This would have been 6 over root 37, but they rationalized it. But WebAssign doesn't always make you simplify, so you could have maybe done the unsimplified version there.
Oh.
6 over root 37 might have worked just fine. But on a test, it would look like this, like a multiple choice paper test.
I'm confused of what they're asking. Like, cot A over 6 equals 6. Like, I don't understand.
Cotangent is a trigonometric ratio. So cotangent of alpha is an angle. So it's saying that the cotangent, or the choshikao, the cotangent, which is the adjacent over opposite, you also have, I mean, they're giving you the abbreviation. But we use abbreviations for all of our trig functions. So cotangent of theta, of any angle, is the cotangent, which is the same thing as the adjacent over the opposite, which is the same thing as the 1 over the tangent. He is a trig function, just like sine, just like cosine.
Well, I know how to find the hypotenuse. I just don't know, like, how to solve the questions.
Yeah, I think the key in this one is like what I showed in the examples in the notes. It's to put that over 1 and realize that they're giving you a ratio. So then as soon as you fill in what you know about the triangle, you solve for what you don't, and then you can just use SOHCAHTOA to find whatever it is that they're asking you for.
Like the third one, when it says 90 degrees minus A.
Ah, that's the one I talked about. There are cofunction trig properties. I thought they showed up in that big table that you guys wrote down in your notes, but from what some people have said, it seems like they didn't. They do show up there in chapter 5. Did we write those down in 4.3? Those properties of tangent being sine over cosine, these guys. Huh. Does your book put the cofunction? I guess I could write them in right here. This would have been your 4.3. Maybe I stole the wrong table of... I can just write them. Co-function identities. Page 281 is in chapter. Oh, it was a little blip in your book in that section. So we wrote down these properties right here. And it was a little blip saying, hey, guess what? You know these co-guys, like cosine and cotangent and cosecant? There are these properties. So I can write them here in your notes. They're called the co-function properties. It's basically a way of, or how mathematically the co comes about. So, let's see, sine, we'll do cosine. Cosine of 90 minus sine's co-function at the complement is the same thing as sine at the original. You can also replace that with, or 90 degrees becomes pi over 2. You can do it in radians or degrees. Who's another co? Cosecant. He's the co-function of secant. And then cotangent is the co-function of tangent. And so when we do our cheater chart, like so, TOA, sine and cosine, right? Sine is S-I-N-E, cosine is co with the sine. What's that mean? Well, sine says I'm 1, 2, 3. Cosine at the complement of 45 is going to be the exact same, which it is. Cosine at the complement of 60 is going to be, that's 30 degrees, the exact same thing. Cosine at the complement of 30, which is 60, is going to be the exact same thing. You guys see this in the unit circle. You just might not have realized this always happens with any cofunction. So I could also do something like sine of 47 degrees will be the exact same thing as cosine of, what would that be, 43 degrees? Does that make 90? Any two angles that add up to be 90, sine and cosine will be the same at the complement. Or cosine of 47 would be sine of 43. There's this symmetry around the circle because of how triangles work. So anyway, Ryan, yeah, I apologize. That was something in the section that I didn't make a big deal of. Because we're coming back to it in chapter 5. But these are called the cofunction properties. So anytime you're at a complementary angle, which is 90 minus, the cofunction will equal the original function or vice versa. I could also flip around. Which is why this guy says you want cotangent of 90 minus, that's the same thing as tangent of the original angle. Or you can think it's the same thing as the reciprocal of the one that you have. Everything else, though, cosecant has ratios, tangent has ratios, cosine has ratios. But if you guys want to grab a quick picture, it is in your 4.3 Jamboard. The cofunction properties. Once again, they're coming back in chapter 5, but they did show up in a random homework problem. I'm sorry, Ryan.
Thank you.
Welcome. Number 10. How similar is it? Oh, not at all, except it uses these properties because it says, hey, can you plug in something and make something look different? So when it says tangent of cosine, tangent of alpha, when it says show that this works, it says show that this works, I can say, okay, I have tangent and I have cosine. So then cosine can't really become anything simpler, but tangent can. If I look at those properties I just talked about, tangent could be 1 over cotangent, which is super awkward, but sine over cosine could be really, really nice. So it's just getting you guys introduced to this idea of how we can use these properties without even having actual angles to make trigonometric expressions simpler because they're related, they're dependent on each other. So really this is the same thing as just, ta-da! Just saying, hey, tangent, isn't he sine over cosine? Oh, sweet. So really, tangent times cosine is just sine. And of course, there are little angles in amongst. So that's exactly what WebAssign wanted, was just, isn't tangent sine over cosine? Look, these stayed the exact same. Nothing changed. But the tangent somehow became a sine over, oh, there's a property for that. I was supposed to answer, but don't forget, Greek letter. How do you find Greek letters, guys, in homework? Yeah, you gotta like click on it, and then isn't there Greek over here on the side? Cool. So then number 11 is super similar as well, except in this one, sine squared stays the same. Cosine squared changes. Well, hold on. What has cosine squared in here? Oh, this guy is a cosine squared, the one with a big yellow star. So if they got rid of cosine squared, well, this one says sine squared is 1 minus cosine squared. Because you can solve for this guy by subtracting him to the other side. Is it possible that I can go the other way as well? And get cosine squared by itself by subtracting sine squared? Okay, I wonder if that's helpful. Cosine squared could be rewritten as 1 minus sine squared. Oh, hey, there he is. And then a sine squared minus a negative sine squared is 2 sine squared. That works. So Noah, I heard you asking me about how to do these. You're kind of playing around with, hey, we can do trig even if we don't have angles using the properties and using some math. But the next question officially was number 16. And number 16 says you got to do some word problem-y stuff, but I think you're just making a triangle, aren't you? You're standing how far from the base of a building? Oh, come on, show me you're awake.
45 meters.
So you're standing 45 meters. Let's make this you. Let's make this the building. From the base of the building, you estimate that the angle of elevation, you're looking at the 86th floor. Why? I have no idea, but that's okay. You're estimating that you're at an angle of 82 degrees. If the total height of the building is another, oh, struggle bus. Well, hold on. I did not leave room for that. We have to make the 86th floor be a little bit lower. This is not to scale, but in geometry we learn never trust the picture anyway, right? 82 degrees, 86th floor. The height of the building is another 112 meters above. No, 121. But that's only above the 86th floor. What is the approximate height of the building? No, they didn't tell me how tall 86 floors is. But what did they tell you?
The total height of the building is another 120 meters above the 86th floor. So there's 121 meters more after the 86th floor.
So I need to figure out this guy, right? Didn't they tell me like a triangle about this guy? So can't I say I know the adjacent and I know the angle and I just need my opposite? Hey guys, what relates an adjacent with an opposite with an angle? Tangent. Can't I do tangent of 82 is equal to x over 45? What's the height of the building? Well, the height of the building is whatever x is. Yeah. So I just need to go ahead and move the 45 to the other side and say, oh, I can find that. No stress. Plug it in, plug it in. Boop, boop. And of course you're allowed to use your calculator because it says round. Pause. Pause. What mode should you be in? Careful. If you're in radian mode, it's going to be all wrong. Because radians measure things very differently than degrees. So make sure you're in degree mode. And then plug and chug. That's 16. Now we're going to 24. It'll be up here for another 5 seconds if you want a picture, if you want to write something down.
Would the final answer have a decimal?
Probably. I mean, I doubt that tangent of 82 would be nice. So yeah. Probably. Which they hint when they say round. Good question, though. 5, 4, 3, 2. Sorry, 5, 4, 3, 2, 1. Okay, number 24. Oh, you guys don't remember reference angles? Reference angles are the little baby acute angle it takes to get to the x-axis from wherever this lands. Hey guys, what does it mean when I have a negative angle?
It's going the other way.
It's going the other way, starting from standard position, which is the positive x-axis. Now, why do I know it has to go into the third quadrant? And it's bigger than 90, right? Now, how much bigger? I don't know, but it's going to be over here somewhere. You could subtract 90, it is going to be 35 past, but what are you actually looking for if you're looking for the reference angle? The little baby acute one to get you to the x-axis in the shortest amount of time. Not going back over the obtuse angle, but just up. So all I need is, well, wouldn't this be 180? So I have 180, I have gone 125, I just need to subtract the 2. I know there's this whole negative dynamic going on, but the long story short is reference angle is always positive. What is this measure? It's going to be 55, guys. Subtract the 2. Subtract the 2. I'm not sure that's something to memorize, but even if you do like memorizing, remember we totally talked about this when we talked about reference angles. I think, was that 4-4? Yeah. We did draw, what if you land, what if you land, what if you land? What do you do? But I think the geometric understanding is a little bit better. Sorry, this will be up for another 5, 4. Reference angle is always positive. We marked it in our notes, but some of you might have put negative 55. No. Reference angles are just the how much distance. We just want the magnitude. 180 minus 125 ends up giving you 55. Don't put the degree mark, it's already there. Yeah.
When you're making a reference angle, the angle is at like the halfway point, so 45 degrees. Would you do the reference angle to the axis? Which axis would you do?
You always go to the x. Now, if it's a 45, you can make a mistake and go the other way and be right at that one time, but everywhere else you'd be wrong.
So the x-axis?
Always the x-axis. Yeah. So then, I think I had the notes up a second ago. Is it this one? So you always go, if you're here, go down to the x. If you're in the third, go up to the x. If you're in the fourth, go up to the x. And what's not shown is the first quadrant, because the first quadrant is already the reference angle. It's already the 0 to 90 angle between the horizontal and the angle itself. But yeah, just go to the x. Whether it's forwards, whether it's backwards, make it the shortest rotation possible to get to the x. Does that make sense, Ryan?
Yes. Just do it always to the x-axis.
Always to the x-axis. And then number 27.
May I use the back?
Yep. Oh, this is so much like the 6/1/1. You guys ready? It's so much like the very first question. We have come full circle. Because they told me what quadrant to draw. My triangle. Geometry doesn't really matter anyway, whatever. Draw a triangle in the third quadrant. What do I know about this theta, whoever he is? What's the opposite side going to get labeled with?
6.
Because who is tangent?
Opposite over adjacent.
So the ratio is going to be 6 to 5. Now, hold on. 6 to 5 is great, but why am I going to go grab a red marker and say, but shouldn't they both be negative in context? I'm in quadrant 3. I've gone left 5 and down 6, but I'm not going to use unit circles. That negative 5 is not a cosine. The biggest cosine can be is 1. It's a ratio. Because Pythagorean theorem would say, don't I have to use a squared plus b squared equals c squared to know the hypotenuse? This is not unit circle. Unit circle says this is 1, but no. 25 and 36 makes 61. Double check my math, right? Oh, not 31. 61. So then they're asking for who or what. Use the trig identity to find what? It says to find the value, and it says the value secant. Who's secant? Oh, no, that's not right. Hypotenuse. What's that? Square root of 61. Over adjacent. Who's that? Don't forget the negative. Don't forget the negative. That'll be good. So we'll check. There he is. Go team. Ready, set. We've done our 1, 2, 3, 4, 5 homework problems. Hopefully that helps. Let's get back to what we're supposed to be doing today. Check out the RenWeb glance of the week. If you guys don't know yet already, this week is AB minimum day to get ready for Sparkle. Next week is Chapel, then AB, and then we're at finals. Our goal in honors pre-cal is to finish chapter 4, which means 4.5, 4.6, and 4.7. We're skipping 4.8. Our goal is to finish chapter 4, 4.5, 4.6, 4.7. Friday is just a minimum day, so I'm fully expecting 4.7 to be pushed over to Monday on Chapel Day, and then have a couple work days before our final exam. We probably will not have a whole other test before finals. And I haven't fully decided whether the final exam will just be a big old chapter 4 test, which could be kind of brutal, or whether it's going to be like a half chapter 4 test and a half cumulative 1 through 3. But either way, we're trying to finish chapter 4, and then we can take a break. So let me get out of WebAssign, let me get out of that WebAssign. And you guys, Lucas, how are we looking? Do we have 4.5 ready?
Yes.
Awesome. Let me go here, let me go here, let me go here, let me go here, let me go here. And the question is, what does a sine look like? Sine, adjacent, no. Sine is opposite over hypotenuse. Sine is opposite over hypotenuse. What does he look like? What am I talking about? We're going to waves, everybody.
Yeah.
We're going to waves. Let's get the basics down today. So as such, the basics of sines and cosines are that if you were to make the x-axis, I don't love how I did this. It's not Lucas's fault, it's my fault. Give me a second. If I was to steal this guy real fast, to give myself a little more room. There we go. And let me steal this guy real fast. Let's see if I can make them bigger. I'm not sure that's that great. That's not really any bigger, is it? Boys in the back, what are you talking about? Do I even want to know? Okay, maybe that's a little bit bigger, but then you can't see that as well. Well, let's do this, and this, and this. Okay, I want you guys to go ahead and get into the y equals on your calculator. Go ahead and get into the y equals on your calculator. I want you to graph sine. Go ahead and get into the y equals on your calculator. Graph sine. But your calculator is going to get really, really mad at you unless you put in like a sine of x. You got to put in a sine of something. So theoretically last year you got to know your calculator. Most of you did not. So getting into your calculator. If you try to do this in degree mode, which most of you just were for homework, it could be really messy. If you do it in radian mode, it's a lot easier. So we're in the y equals. You guys are typing in sine of x. A lot of you guys were just in degree mode. Where's the wave? Ugh. Where's the wave? There is no wave. It looks like a line. It looks like a lame line. Why does it look like a lame line? If you guys hit zoom, do you see that there's a zoom trig? Right now I'm in a 10 by 10 window. And I'm in degree mode because that's where we just were for that physics-y type problem that we were doing a second ago. There's no wave. I just said we're doing waves. What the heck? Okay, hold on. What if you hit zoom trig, which says, oh, you're in degree mode? Oh, there he is, but what happened? Nothing changed. I'm still in degree mode. I still put in sine, but what did? Perspective. It went from being a 10 by 10 to being negative 495 to 495, which is super awkward. I much rather would have had negative 360 to 360, but long story short, it's going by 90s. It's giving me perspective and saying, oh, that's right, it takes 360 degrees to do a whole cycle of a maximum and a minimum, of a highest amplitude and a lowest amplitude. One full cycle of the wave takes a whole lot longer in degree mode than, well, hold on, what if I realize my mistake and I'm like, oh, radians. Radians are more natural. Ugh, what just happened? It takes way more degrees to measure a circle than it takes radians, remember? So if you do zoom trig, it's going to be like, oh, you're in radian mode? You probably want your numbers a lot smaller. So new zoom that you might not have used last year because you weren't using your calculator, zoom trig says, hey, I'll look at degrees radians and give you what you want, probably. Guess what you want and usually be pretty close to spot on. So here's the wave, but hold on. That's for sine. What's different if I was to have you guys graph cosine? And remember, if you try to do it without an argument, it doesn't make sense. You got to say of an angle. How similar are they? Pretty similar. Actually, their shape is the exact same, just isn't there a shift?
Yeah.
Hey, Ryan, didn't you ask me earlier about that whole weird 90 minus thing? Right? That whole 90 minus says, like, hey, they're the exact same values, just at different places. So if this one's at 180, hitting the axis, that one's going to be hitting the axis at 90 minus that. Actually, that's an awkward one, so I'm using different quadrants. If I was in the first quadrant, 45 minus 45, at 45 they're the exact same and they intersect. So without even using my feature, I know that that first intersection point, well, it's going to be awkward if I use radians. Because radians, pi over 4 is not a nice number. What's 0.785? Oh, that's pi over 4. So while radians is really nice for like zoom standard, radians is really nasty for doing things like intersections. Degrees might be easier for things like intersections because their numbers are nicer. So if I do zoom trig, and I try to do that nice little intersection point, I think I would rather be in degrees than radians. Oh, 45 degrees. Okay, that's nicer. But both sine and cosine. I actually want to change my master. I'm going to grab a quick picture before I write on it. So waves come about when I say, let's make the theta or the angles into the x-axis, so that's not the unit circle anymore. And I put things like, hey, let's put pi, let's put 2 pi. So then the little halfway tick marks would be a half pi or 1.5 pi. I take my entire rotation around a circle and I put it on my x-axis. And then I ask myself, what are all those different values? That sine can be. Biggest being 1, smallest being -1. And see what happens if I was to have like technology map them all out. If I was just to use my unit circle ones, I would know the 0, I would know the pi over 3, which is like here-ish. I would know the pi over, I guess I would know a few more than that. Because that's pi over 2. I sine of 0, and then I would know a few right here leading up to 1, then I would know a few more. But if I was to keep going, I would end up with this nice little wave that's going to just keep on repeating over and over and over again as you keep going around and around and around a circular pattern. So some people, if they get to know this function really well, some people, if I say, what is sine of 0? They're like, oh, sine of 0 is 0. Why? Because sine always starts in the middle. Whereas cosine of 0, well, if I was to do the exact same thing with putting my angles, pi and 2 pi on the x-axis, every halfway point is going to be 1/2, and so pi over 2, and then 1.5 or 3 pi over 2. Still going to go up to 1, still going to go down to 1. It's going to have other things in between, like my 1/2 and my root 2 over 2 and my root 3 over 2 and my negative 1/2, negative root 2 over 2, negative root 3 over 2. All those could be marked. They're just really awkward numbers, so we usually don't. We usually just kind of get that 1 up there, get that negative 1 down there. But a cosine curve, he says, no. I start at 1, and then I cycle through. Sine starts at 0, cosine starts at 1, and then they repeat. Then all of a sudden we have this whole, like, triangles from geometry relate to circles in Algebra 2 and Pre-Cal, which relates to waves, and now we have triangles and circles and waves all kind of having this weird, like, related behavior. However, I was really bad at drawing that because it should be the exact same height and there we go. Every single time. Don't know why Zoom is updating. I don't even have it open. That's awkward. And so what I do to keep myself a little bit honest, because this is kind of scary, is to give myself little marking lines as far as how high does it go, how low does it go. And if you guys remember from last year, there are all kinds of special vocab that describe these different features, but these are what we call the parent functions of sine and cosine. Does anybody remember the name of it from last year, like what these waves are called? It actually has more to do with that one than that one.
Sine waves.
Sine,
Fading waves.
sinusoidals. Like sinus?
Yeah.
Sinusoidal curves. You can think of them as waves. Of course, I mean, they are graphs, technically. But sinusoidals. Sinusoidal curves, sinusoidal waves, sinusoidal graphs. They both have the same name because they're both the same idea, just they're happening at different places. The sine function could be like a pendulum or something on some sort of fulcrum. And a sine says you start in the middle, you start at rest, and then you're being displaced. You would go back and forth if it was actually loose. Sine says you start in the middle and then you get displaced. You start at rest and then you get displaced. Cosine says you start displaced and you get let go. That's kind of the difference. One says I start with some displacement, the other one says I start at rest. So there are snazzy names like equilibrium is in the middle. Equilibrium is in the middle, which we can also call the sinusoidal axis. We also have how high or how low it goes. I said it a couple times today. Do you guys remember the vocab word for how high or how low a wave goes?
Range.
Yeah. Range kind of says like the lowest to the highest, but the how high up
Vertex.
versus the how low down
Restriction.
has something to do with turning up your music.
Volume.
Keep thinking. If you turn up your music, some people are like, why are you, or you should
Turn it down.
Yeah, but they use a different. They use a different. Turn it up, turn it down. Man, they're really.
Lower, higher.
Adjust.
It starts with an A.
Sound.
Audio.
Amazing.
Fix.
Adjust. Wait.
It can also be what projects the sound out. Some people
Auto tune.
Amplify.
amplify, amp it up, amplitude, amplifiers.
Gosh, stop being smart, guys.
The amplitude is how high from equilibrium, which is actually the exact same distance as how low. It's not a positive or a negative, it's just a, what's that distance from the equilibrium to the highest crest or to the lowest. There's the amplitude. If you amp it up, or amplifiers. Sound amplifiers. Yeah, no.
Didn't we watch a video about how like the waves can go into like 3D, like they can go into the z-axis?
It's all weird and crazy looking.
Does the cosine graph go?
I remember that video.
Go on to pi or?
There's like two dots spinning around. No,
Yeah. Does the cosine graph go like over 2 pi or is it
Oh, yeah. They hadn't drawn my guidelines, and that gets me in a lot of trouble. So cosine should be back up at its maximum, finishing its cycle at 2 pi. There you go. So then sine cycle is from equilibrium to the max, equilibrium, min, equilibrium, whereas cosine cycle is maximum displacement, go all the way to the minimum and then back. So they're both returning to where they started. Sine's just a little bit weird because you go through the equilibrium 3 times, whereas cosine only goes through equilibrium twice. But this cycle gets repeated over and over and over again, unless acted upon by an outside force. There's some physics in there. And same thing with the parent function of cosine too. Okay, but I do have like these terms kind of, oh, I didn't write this one out. So some people, when they're trying to remember cosine of 0, they think about the graph because the graph starts at 1, whereas the sine's graph starts at 0. You have other ways of remembering the unit circle, but not like the 1/2 and the √2/2 and the √3/2. They're awkward decimals. They're not super easy to remember here. But like the axes, like the maximums and minimums, they are a little bit easier to remember if you know the graph. So these are called my 5 key points, and each graph has them. And they happen every 90 degrees or every pi/2, which is what you see marked here. Unless, again, acted upon by an outside force or transformed. So those points that I just marked are the key points. Where I have sine. You guys did one of your video tests on this. Cosine, if you were here last year. Sine versus cosine. This is one cycle of each. And these 5 key points include intercepts with the sinusoidal axis. I'm just going to say with the SA, we'll label him in a sec. It's going to include at least one maximum, at least one minimum. And if you can get these 5 key points, even if the thing has been stretched or shifted, if you can get those 5 key points, all you do is say, there's one, I'm just going to repeat it forwards and backwards, and I have the whole thing. So when we're graphing a sine or cosine, we're trying to get the 5 key points, whether from top back to top or from middle back to middle. And if you guys look at this, these sections are actually being cut, if I was to show this, into fourths. So I have 1/4 there, 1/2 there, 3/4 there, 1 whole here. I have 1/4, 1/2, 3/4, 1 whole. So 5 key points, but in between I have 4 key sections. Andy, you have a question or just stretching, bud?
Oh, it's stretching.
Okay. So like if it's something basic like this, they say sketch 2 sine. I mean, all this is a vertical stretch by 2. That's it. There's one change, and one change alone. If all that's different is a vertical stretch by 2, all I have to do is take my basic sine curve, which goes up 1, down 1. All I have to do for vertical stretch by 2 is know my basic sine curve. I have my 2 pi, my pi, I've cut those in half, so I have my 1, 2, 3, 4 different intervals. All I have to do is take my basic sine curve and say stretch it. Stretching it would say have it go up to 2 instead of up to 1. 1 times 2 is 2. 0 times 2 is still 0. Taking all my y values and I'm just doubling them. At pi I would have 0. 0 times 2 is still 0, but negative 1 times 2 is going to be negative 2. I could take my 5 key points and multiply all of them by 2. Then I could just, I'm going to draw little arrows, but I could just keep repeating that cycle. Unless acted upon by an outside force, which would need to show up in the function, or given another transformation, that's good to go. But what if it gets messier is the question. And that's where things get interesting. What if it gets messier? And that's where things get interesting. We have all these different transformations that can show up. We have our axis. Which will show us a vertical shift. We're going to have our middle, which is normally a 0, but if there's something else that's being added, all of a sudden that equilibrium just got shifted somewhere else. A is for, he's the easy one, A is for amp it up, amplitude. So like we just saw, multiplying by a 2 in front made the wave go twice as high and twice as low. So the amplitude is the how high, how low, but how that's going to actually translate is that the maximum is going to be at y plus a. And the minimum is going to be at, well, I guess I should just say what the y is. So it's going to be d. The min is going to be at d minus a. B is going to have something to do with my period. It's going to be the horizontal dilation. We're going to have to see next time that has something to do with the period, aka how long the cycle is. I'm going to put a question mark by that, and we'll come back to period next time. And then C over B, if you guys notice right now, it's kind of weird. Some of them have the B and C all in the parentheses. Some of them just have the B outside. Actually, this is the nicest one to graph. But sometimes you got to get there. But C over B is going to be the phase shift. Like the phases of the moon, sort of. So this homework on 4.5 is going to be showing up on WebAssign. I'm going to change the deadline to have it due Friday at 8 a.m. We need to do a little more work, but you guys have seen this before. So we're going to work on waves on Wednesday. Bye, cool kids. Get that homework done by tonight.